Hi guys, in this video we're going to talk about a lot of different things that kind of all different graphs that relate to each other. So the first one is a dot plot. Basically, each dot represents a number. So there are 4 ones, 4 zeros, 4 1, and so forth. With a dot plot, sometimes you'll also see them with X's, which is a line plot, but same similar situation. Okay, so now we're going to find the mean, median, mode, and range. So let's start and write our data set. So we have 0. Ooh, that's not a good color. Let me get a different one. Let me go with white. So we have 0, 0, 0, 0, 1. No 3s, 2 4s, 3 5s, 2 6s, 7, and a 9. Okay, so go ahead and add all those up. Okay, and we get 60. And then you're going to do 60 and then divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We're going to get 3.3 is going to be our average, our mean. The median, let's cross them out. Okay, so 2 and 4, halfway between 2 and 4 is 3. Mode, the number that occurs the most. These are easy because you can see the highest. So this is going to be 0 and 2. And then the range is going to be 9 minus 0, so it is 9. For this one, it says, how many students read exactly 6 books? Okay, so we're going to look at 6, and there are 2 students. What fraction have read 0 books? And then it says simplify. So there's 4 students that have read 0 books out of the total. What did we say the total was? 18. So 4/18, we just need to simplify this fraction to 2/9. And then what fraction is more than 2? So that's not going to include 2, so that's more than 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 18 becomes 1/2. Okay. What percent of the students read 2? So that was 4 out of 15. We said 15. Oh, nope, 18. Equals, remember, x over 100. Set it up like a proportion every time. So we're going to do 100 times 4 divided by 18 equals 22.2. So it's going to be 22%. And then one of the students read 5 or more. So that includes 5. So 1, 2, 3, 4, 5, 6, 7 over 18 equals x over 100. Cross multiply, divide. So 7 times 100 is 700 divided by 18 gives me 30. The 8 makes it round up to 39%. And then what percent of students read less than 4? So that doesn't include 4. So that's 4, 5, 6, 7, 8, 9 out of 18 equals x over 100. That'd be 900 divided by 18 gives me 50%. So this is what is called a histogram. So a histogram is different than a bar graph for 2 things. Number 1, the bars touch. And number 2, there's ranges along the x-axis. So see how it's 0 to 2, 3 to 5, and so forth. So that is the difference between a histogram and a bar graph. Okay, so the range is along the x and the bars touch. Okay, we're going to talk about a few other things real quick and then we'll kind of bring it all together. So we're going to talk about independent variable and dependent variable. Independent variable, you probably remember this from science. Independent is what stays the same. So that's going to be your x-axis. And then dependent variable is what changes, which is your y-axis. So the amount of time that goes by depends on how long my hair is, or depends on how long your hair is. Yep. So the independent variable is the cause, what you can control, time, and then the effect is the dependent. So let's look. Independent is located on the x. It is the cause, usually time. It's what's consistent, x-axis. And then for y-axis, that's the dependent. It's the effect, the output, the solution, the cost, distance usually, and it's what changes. So what I like to do is I like to draw an I and then a D for independent and then dependent. For independent and then dependent. Okay? Independent and then dependent. Okay, so let's look at this graph. So this has a frequency table with a histogram. So notice it's the number of cappuccinos, had tally marks, and then the frequency. And then they made the graph out of it. Our independent variable is the number of cappuccinos made per hour. Then the number of occurrences is the dependent. Okay, however many made, number of occurrences. Okay. So here we go. What's the title of the x-axis is pulse rates. The y, frequency. How many patients had a pulse rate between 80 and 90? So we can look like right here. That's going to be 5. What is the range of pulse rates that was common amongst most patients? So which is the highest, is that's what it's asking, was 90 to 99. How many more patients had a pulse rate between 100 and 109? So sometimes I like to just go ahead and put my numbers so I don't forget them. 7 and 4. Okay, so how many had 100 and 109 was 4. How many had 60 to 69 was 1. So 3 more. Then how many patients had a pulse rate of 97? So because it's a histogram, we don't know how many had 97. We know the range and we know what each one could have been. We don't know the exact. So you will write not enough info. They don't tell you. If they had a histogram or a frequency table, then they would tell you. How many patients had a pulse rate of more than 99? So that's going to be 4 because that's that higher range. Independent is your X, so the pulse rates. And then the dependent is the frequency. So here we go. Let's make a histogram. So we're going to put our numbers into the frequency table first. I'm going to do tally marks. So I'm going to start with 8. It's going to go here, 2, 4, 7.5, 10, 11, 5, 6, 8, 12, 11, 9, 6.5. Okay, so for this one, notice I did the tally mark. I crossed it out. 10.5 and 13. Okay, so let's 1, 2, 5, 5, 2. So along the X, we're going to put 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14. Got 0, 1, 2, 3, 4, and 5. So here we go, 0, 2, and then 2. And remember, the bars need to touch. And then back down to 2. Boop. Histogram. So what's the difference between 6, 8 and 9, 14? So notice it's 9 to 14. So that would be 2 would be the difference. What fraction is between 3 to 5? So there's 2. Then we need to figure out the total. So that's 10, 11, 12, 13, 14, 15. So 2/15. Can you tell from the histogram how many 7s there are in the data set? From the histogram, no, because it is a range. Okay. So the title is the age. The y-axis is the number of winners. The fraction between, okay, let's do our totals. So 2, 5, 6, 8, 5, 4. Between 20 to 29 would be 2. Okay, but it's a fraction, so we got to do 2 out of something. So we got to figure out our total. So take your calculator, use your calculator, totally fine. So 5 plus 2 is 7, plus 6, plus 8, plus 5, plus 4. It's going to be 30, so 2 out of 30, which equals 1 out of 15. How many more winners? Oops, that got covered up. Let's see if we can move it. Yep. So how many more winners were between 50 to 59 than 20 to 29? So 50 to 59 was 8. 29, that was 2, so the difference is 6. How many winners were above age 39? So we just need to add those. So 6 plus 8 plus 5 plus 4 gives me 23. How many were 41? Not enough information. And how many from 20 to 39? So we need to combine those, and that would be 7. The independent is the age. And then that would be the number of winners. Okay, let's look at it more in a graph. So for a graph, the X is always going to be your independent, and the Y is always going to be your dependent. So your independent, your dependent on a graph. Okay, let me make this a little neater on the table. Okay, and then in an equation, we have our X and our Y. And notice our unit rate is our 2. That's our unit rate. We already did that unit rate. So here, time, so we've got independent, dependent, independent, dependent, independent, dependent. Same thing. Independent, dependent. The only difference is it's sideways. Independent, dependent. The input's your independent, the output's your dependent. So let's do it from a graph. So you're independent, you're dependent. Independent, you're dependent. The number of months affects your weight. The time affects your distance. Number of items purchased affects the cost. Time affects the distance. Okay, so let's do it from an equation real quick. So Brian leaves at a rate of 45 miles per hour. That's our unit rate. Which equation matches? H is the number of hours and D is the total distance. Okay, so we're going to add it or we're going to multiply it. We're going to multiply it. So H is your independent and D is your dependent. Charlie purchases flowers for her mother at a cost of $2 per flower. Which equation matches this situation? T is the total cost. F is the number of flowers purchased. You're going to multiply it again. F is your independent. D or C is your dependent. Okay, make sure you have all this filled in.